This conference will now be recorded.
Okay, guys. So last week we mainly discussed about the operators. Now, under the operators, almost 95% operators we discussed, their syntaxes, their working principle. Now, which operators are left, sir? Of course, first bracket open, first bracket close is the operator. Explicitly we have not discussed, but whenever we learn function concept, this first bracket open, first bracket close will come into the picture. Like third bracket open, third bracket close is also an operator. When it will be discussed, when the array will be discussed, this will come into the picture. Next, dot operator, arrow operator. These two operators are mainly related to structure concept. So whenever we will go for structure discussion, these two operators will definitely come. Post increment and pre increment is a big discussion, not only here at the operator level, in different level, in loops, in functions, so many places will be there where this post increment, post decrement operator will come into the picture. So these are mostly the operators which currently we are not in a position to discussion, not in a position to discuss, but with time, with different chapters comes into the picture, we will go for a discussion of these operators. Next, this is already we discussed logical not, bitwise complement we discuss. This is another one, indirection star, or some people call it as a value at address operator. This also related to pointer concept. This also related to pointer concept. So when pointer will come, this operator will be discussed explicitly. Address of operator, we know that we discussed not bitwise and it's address of operator. Every time scanf statement ampersand comes into the picture. Unary plus, unary minus, minus 5 is the unary minus. If you write only 5, that means unary plus, normal thing. Size of operator we discussed. Next, and after that, one vital unary operator we missed, that is called typecasting. That is called typecasting. So today we are going to learn this one, this typecasting. Except that, see, multiplication, division, modular division, plus minus, left shift, right shift, we explored. Between conditional operator, sorry, comparison operator, greater than, greater equal to, less than, lesser equal to, we discussed. Equal to, not equal to, we discussed. Bitwise and, XOR, or we discussed. Logical and, logical or, logical not also we discussed. Logical not is a unary operator. This is nothing but conditional operator, already we discussed. Comma operator also we discussed. An assignment operator, equal to, we discussed. Shorthand assignment operator, in few questions we discussed. This will come, this fellow will also come. Now first let us concentrate on typecasting. Typecasting operator. See here all operators are unary operator because they work on one operand. That's why they are considered as a unary operator. So what is typecasting, sir? Typecasting is basically a conversion from one type to another type. What is typecasting, guys? Typecasting is a conversion from one type to another type. Typecasting. Today I will share all the notes till now. What is typecasting? Typecasting, a typecast is basically a conversion from one type to another. Typecasting is basically a conversion from one type to another. Now, what are the different type of typecasting we are having? Two different type of typecasting we are having. There are two types of type conversion. What are the two type of type conversion? Number one, it is known as implicit type conversion. Implicit type conversion means automatic type conversion, automatically happens. I will show you with programmatic explanation. Implicit type conversion or automatic type conversion. Another one is there, that is called explicit type conversion. Another one is there, that is called explicit type conversion. So these two type conversion we are having. One is implicit or automatic type conversion. Another is explicit type conversion. Now, what is implicit type conversion? What do you mean by implicit type conversion? Implicit type conversion means we are not responsible. Compiler is responsible to perform this type of typecasting. We will not do anything. Everything will be taken care by the responsibility will be taken care by the compiler. The compiler is responsible to perform this type of typecasting. In C programming language, C automatically converts any intermediate value to the proper type. Any intermediate value to the proper type. What it means? Converts intermediate value to the proper types. What it means? It means that, suppose for example, for usual conversion, for usual typecasting, it follows a particular order. What is that order? I will let you know that order. But before that, let me go for an example and then I will show you what is that order that actually it follows for automatic typecasting. Say here, just I'm writing one program here, int main. Say for example, I'm having one variable of what type? Double type, double A. And I'm having two int variables, int x is equal to 6, y is equal to 4. Now what I'm doing here, I'm writing A is equal to x by y. A is equal to x by y. One double variable, two integer variable, I'm taking their division, as simple as that. I want to print the value. Which value? Sir, I want to print the value of A. If you want to print the value of A, what format specification will be required? Because you are using double. So for a double, what format specification will be required? It will be like elif, long float. It will be like elif, long float, return 0. Now in this case, what will be the output that will be coming, sir? What output will come? Observe here. This is my coding here, sir. What is the output that will come here? This line, no problem. This line also no problem. Third line, simple. X by y means what? 6 by 4. 6 by 4. Here what is going to happen? 6 divided by 4. As simple as that. What operator you are using? Normal division. Normal division gives us what? Quotient. What it gives? Quotient. This is called quotient. This is known as quotient. And this is known as the remainder. This is known as remainder. Normal division gives us what? Quotient. So after division, what is the value of A? Or rather, after division, what is the value of this quotient? 1. Integer division, no, sir, 1. Now what is the statement is becoming? A is equal to 1. A is equal to 1. A is what type and 1 is what type? Sir, A is a double type. one is a int type, one is double type, one is int type. What will happen? The lower data type will be automatically converted to higher data type. So how we will remember, sir? How we will remember this thing? Observe here. Say for example, what is the exact, where it is, guys? Yeah. So what is the exact chart, sir, that it follows for conversion? First, it is int. On top of that, we are having unsigned int. Now these words are not new anymore to you. Unsigned int. After that, we are having long, then unsigned long. Next and after that, long. That is also a data type, guys. Long. I'm not satisfied with long value. I want much more larger value than long data type. Then you can go for long. Next, we are having unsigned long followed by unsigned long. Then we are having float. Then we are having double. Then we are having long double. This is usual arithmetic conversion. This is usual arithmetic conversion. That means what? This int, it will be automatically converted to what? Unsigned int. Similarly, unsigned int will automatically converted to long. He will be converted to unsigned long. He will be converted to long. He will be converted to unsigned long. He will be converted to float. Float will be converted to double. These things you don't have to do anything. Implicit it will happen. That's why called automatic typecasting. So currently, as per our example, the value of A is 1, which is int type, and A is double type. Now, as per this chart, the int data type will be automatically converted, converted to double. And the value of A will become, after conversion, the value of A will become 1.6 zeros. How many zeros? 6 zeros. Why 6 zeros? That's a convention. For any real number after decimal point, 6 zeros get printed. That's a convention. Based on convention, we just have to know that it's a convention. Now you see here, if I execute this code, and I'm printing with %lf, so 100% it should print 1.6 zeros. Check it out. 1.6 zeros. So who converted your 1 to double type? You converted? No, sir, I didn't convert it. It is implicitly happening. This promotion takes place implicitly, internally. That is why it is considered as implicit typecasting. The usual arithmetic conversion are implicitly performed to cast their value to a common type. So the compiler first performs what? Integer promotion. After that, If the operands still are having different type, next level. Still different type, next level. So continuously they are converted to the upper type. Which is which upper type? The upper type which is there in the hierarchy. The upper type which is there in the hierarchy. So here also int started from the beginning, gradually converted to double. That's the reason we are getting here as the output 1.60. No, sir. I don't want to get 6 zeros. Then what you are expecting? Sir, I want to get 1 point. If you divide 6 by 4 now, 1.5 I want to get, sir. 1.5 by 1. Then you have to go for explicit typecasting. Then who is responsible for that? Programmer is responsible for this type of typecasting. Typing in the editor, no, that's why whenever we type 4, it thinks that it's a loop. And these things come automatically. For this type of typecasting. Now, when it is required, guys, it is generally required whenever we are assigning bigger data type value to smaller data type variable. Generally, this is the case where explicit typecasting is required. What is the syntax, sir? What is the syntax? Syntax in C. What is that? Simple. Type followed by expression. What is this? Type indicates the data type to which the final result to make it of a particular data type. Let me bring one example here. Suppose in this code, I'm not expecting that 1.60. I'm expecting 1.5 as the answer. What we will do here? In this case, you are not allowed to change the data type. Let us assume. If you are allowed to change the data type, then no problem, sir. If you are allowed me to change the data type, then no problem. To make it float, now definitely 1.5 will come and followed by 5 zeros. See, think guys, this 5 have no relation with 5 zeros. Thing is that after decimal point, 6 digit will be printed, whatever it may be. But suppose you are not allowed to change the data type here. You have to work with int x and y4, int y. You are not allowed to change the data type, but still you are expecting that result. Normally not coming. Normally not coming. Not coming. What we will do? Here out of x and y, any one of them, your choice, either x or y, you can make that explicit typecasting. What is the syntax? First bracket open, first bracket close. Then the required data type, what you are expecting, double. Required data type, whatever expecting. Yes. Now here, what is the beauty? Don't think that throughout the program x will now become double. No. Throughout the program means after line number 5, x type is still int. 7, 8, 9, 10, 11, 12. As long as the program is there, the type will be int only. But just in this line, you are asking x, can you please behave like a double? Can you please behave like a double? Just in this line, nowhere else. Then X will tell, okay, I will do that, but before that you have to write that double inside first bracket open, first bracket close. Then I will behave like a double. What is happening here? I wrote. Then immediately, now this division is becoming 6 point, what is that, guys? 6 zeros. 6 digit after decimal point is always whatever is the value. Divided by. Why I have not typecasted yet? Why I have not typecasted yet? What is this y? 4. Now you see, one is double type and another is int type. Again, automatic typecasting will come into the picture, na? Two different data type. Automatic typecasting will come. Arithmetic conversion. This int 4 will automatically typecasted to 444. That means 4 followed by 6 zeros. Now the division becomes actually 6.60 divided by 4.60. That definitely 1.5 followed by 5 zeros. No, sir, it will come. It will definitely come. No, sir, I will not do this to X. I will do this to Y. You do this. What will happen? First fellow is what? 6. Next fellow is what? 4.60. One is int, another is double. What will happen? Here also automatic typecasting will come into the picture and make it to double. Here also result will become 1.5 followed by 5 zeros. Means after decimal point 6 digit. This is what is known as explicit typecasting. Who is doing that explicit typecasting? Is compiler is doing or you are doing it? No, sir. I am doing this conversion explicitly as a programmer. That's why what we said, programmer is responsible for this type of typecasting. What is the advantage you are getting? Sir, when I am not performing this typecasting now, sir. When I was not performing, and anything you can do, I'm showing this with X. Sir, whenever I was not making the typecasting, sir, output was not coming perfectly. Some digit was lost. This should come. This is what is coming when I was not doing the explicit typecasting. So by doing the explicit typecasting, what benefit we achieved? Sir, the benefit that I achieved is that maybe a chance of loss of information. There may be a chance of loss of information in this type of typecasting. So whenever we are assigning higher data type value to lower data type variable, the most significant bit will be lost. The most significant bit will be lost. I don't want to lose anything, sir. Earlier I was getting 1.60. Some digits, some bits we are getting lost. I don't want to get it lost. Then go for explicit typecasting. So this is where typecasting is important. And remember, typecasting is also a operator basically, where it stands under the category of unary operator. Because whenever you typecast, you are basically typecasting on one particular operand. What it indicates? It indicates that it is a unary operator. Let me give one example, guys, based on this. What is the question number currently we are having? Achha, up to question number 22 I prepared, okay, with this everything written properly. Up to 22, 23, 24. I think up to 24 I prepared. 1 minute. This is 22, guys. $23. Okay. 24. Up to 24 I prepared. From 25 onwards I have to prepare. I will do that for you. 25, 26. These are roughly done. 27. Already we practiced this, na? 28 last week, last class. 29. 30. So last week we practiced at least 30 questions, guys. Yeah. Question number 31. Let me tell you. Int a is equal to 9. Float x. X is equal to a by 2. X is equal to a by 2. Printf. I'm writing here percentile f, and here I'm writing x. Tell me, guys, what is the output here? Perfect. Very good. Chetan, very good. What about others? What is the output here? Yeah, good. 4.60. Execute, compile and run. Perfect. Next, in this coding, I'm making a little bit change. What change, sir? Today we have learned explicit typecasting, na? So I will make a small change here. What is the change? I will make here float. What is the output this time? What is the output in this case? What is the output I will get in this case? Yeah, 4.5 followed by 5 zeros. 4.5 followed by 5 zeros. So I think now you're feeling comfortable with this implicit and explicit typecasting. Let us move further. Four 4.6 zeros and 4.5 followed by 5 zeros. These are the two cases. Okay. Let us move to the next one. Now almost all the operators are discussed. Now anything arbitrarily, you people have to give the answer. Say for example here, relational operator I discussed, na? Relational operator discussed, conditional operator discussion done, shifting also done. Now let us assume this one. Int a. Int I is equal to 1 minute, guys. Yeah, come back students. Int a, int I is equal to 4. Here a is equal to 24 logical or minus minus I. I'm printing here printf percentile d a comma I. Yes. What will happen in this case? What will be the output? Everyone, what is the output, sir, in this case? Okay, let me tell you. Already we discussed about the logical OR story. In logical OR operator, we know that if first part is true, if the first part is true, control never goes to the other part. Control never goes to the other part. Remember guys, if the first operand is true, control never goes to the other part. So what will happen? Is 24 is a true value or not? Any other than 0 is true value. Any value other than 0 is a true value. Minus 24 a true value, sir. So will the control will come to the other half? No. Will this minus minus I will be executing? No. So I value will be remain what? 4. What about a value? Sir, it's a true now. True value means now whatever is the other thing I am not interested to know. Total result will be true. True means 1. So the value of a will become 1 and the value of I is as it is 4. Chetan, 1, 4. Execute, compile and run. Okay na? Understanding why it is coming as 1, 4? Yeah. So you have to always careful about this logical OR operator. If the first part is true anyhow, control will never go to the other half. Okay, sir. So what it is? 1, 4. 1, 4. Let us take another example. 1 minute. OR operator. Okay. Let me tell you. Here I am having int x is equal to 4, y4, z4. If x is equal to y is equal to z, printf c, else printf c++. Tell me, what is the answer? Observe. What is this operator? Sir, relational operator equal to. Acha, before that, guys, how will remember the entire table? This precedence and associativity table, how will remember, sir? Right? What is the shortcut for remembering this table? Just I will ask you to remember this thing. Not entire table, remember this fellow only. And here it's not difficult to remember. Why? Because from your childhood you know that, na, that Badmash rule. Am I audible, students? Others, please do confirm once. Am I audible? Am I audible, guys? Yeah, Modulina, from my side it's okay, right? You just log out and log in once. I think problem will be resolved. Just log out and log in once. Okay. Yeah. Come back. Now, how do you remember, sir? How do you remember this entire precedence associativity chart? Such a big one, sir, bigger one. How can I remember? Okay, my suggestion is you just remember up to this. And here also it's not difficult to remember because due to that Bodmas tool, you know, na, from that you know that first bracket open, first bracket close is having high precedence. Just remember that. Once you remember up to this, along with automatically third bracket open, third bracket close, very easily you'll be able to remember. So till now nothing to remember because everything already you know that. Okay, then I'm telling remember up to this only. Dot operator, arrow operator, and post increment, post decrement. Here a big thing is there, guys. Later it will come. See, post decrement, post increment, it's having high precedence compared to pre increment, pre decrement. Post increment, post decrement is having high precedence compared to pre increment, pre decrement. What I ask you to remember, just these two. Who is having high precedence? Dot, arrow, post increment, post decrement, and the remaining twos are automatically coming now. First bracket open, third bracket, first bracket open, first bracket close, third bracket open, third bracket close. Next, the entire thing to remember, I will ask you remember this thing. You ask black. You ask black. Now actual spelling is what? Actual spelling is what? You ask black. This is the actual spelling now. But forget about correct spelling, because while doing WhatsApp we also write MSG, that is for message. But is it the spelling for message? No, but still we write na. Pronounce, if I ask you pronounce this, what you will pronounce? Message, sir, but not the correct spelling. Similarly here, you ask black, you remember in this fashion. You ask instead of KC and black, BLAC, BLAC black, BLAC black. Don't go for correct spelling here to remember this. What is this U? Unary operator. What are the unary operators? Already you know that. Already we practiced. Pre-increment, pre-decrement, logical not, bitwise complement, address of operator, unary plus minus, size of, typecasting. That's for unary. U for unary. A for what? Arithmetic operator. In arithmetic operator from your childhood you know that. Sir, multiplication, division, modular division having high precedence compared to plus and minus. Yes. In the table, this two part is coming by that, just by remembering that. Next, you ask S for shift. S for shift. Let's see here. After this shift, left shift, right shift. Next, ask C na comparison. These many comparison operator we are having, but you see this fellow are having high precedence. How to remember? Remember greater than na, greater than, less than, greater equal to, lesser equal to. They are having high precedence compared to that of equal to and not equal to. Easy. Next, you ask black. Who will come? B. B means bitwise. In bitwise you are having, sir, bitwise and, bitwise or, bitwise or. How to remember? See, and is a 3-letter word, zor is a 3-letter word, or is a 2-letter word. 3 is more than 2 na. That's why these two are having high precedence than that bitwise or. Don't think it's logically, for your understanding and remembering purpose I'm telling you this story. Now between and or both are having 3-letter, but it starts with A, it starts with X. A comes first na. Bitwise and first, zor second, or third. Next, black, L. L means logical. How many logical operator? 3. Logical and or not. Not already comes under unary operator, already done. Comes under unary operator, already done. Logical not. What remains? Logical or and logical and. And is a 3-letter word, sir. 3 is more than 2. Then and will have high. Then after that, you see here BL. Then see the gap between. See the gap between L and A. So much gap. Why so much gap? Why? We're asking now. Asking means conditional operator will come. Ternary operator or conditional operator. After that again A. This time means assignment operator. Equal to, plus, equal to, minus, equal to, multiplication, equal to, bitwise and is equal to, left shift, equal to, done. C means comma operator. Easy na guys, now to remember this. You ask black, sir, what is unary minus C? X is equal to minus 5, minus acting as unary operator. X is equal to A minus B, minus acting as binary operator. Unary minus, binary minus. You understood? I hope now very easily you will able to remember this chart. You ask black. So I ask you very small thing to remember. This thing. Dot, arrow, post increment, post decrement. Remaining top to bottom, everything is automatically coming. Just by remembering, you ask black. Now here in this code, sir, both are assignment operator. Then what? Sorry, both are relational operator. Then what you will do? Sir, I have to go for associativity. Regarding associativity, very easy guys. Remember, conditional operator, assignment operator, and unary operator associativity is right to left. Remaining everyone is left to right. One more time, conditional operator, assignment operator, and unary operator associativity right to left. Remaining everyone is left to right. Now here, sir, what we are going to do, as per the question is concerned, having equality operator 2 times. So no question of precedence, because with whom I will compare? Both are having same operator. Na? Then go for associativity. What is the associativity? Sir, left to right. What is that? Left to right. So now very easily you will able to give the answer. Sir, is Z is equal to Y? Yes. Relational operator, whenever it works, what result it returns? 1. So now it returns what? 1. Now what you are checking? X is equal to 1. X is what? 4. Is 4 is equal to 1? No. That means it is returning what now? 0. If 0, is this line will execute? No. Where the control will come? Else what? What will be executed? C++. Understanding? Everyone understood, sir? Why this not enter in the if block, but why it should enter in the else block? Can I move further, guys? Everyone got clarity? Yes. Let us go for the next one. Very simple one. Printf %d 1, 2 plus 3, 4. What is the answer? Precedence and associativity will definitely come into the picture. What is the answer, guys? Very simple. First you tell me, no. First you tell me how many operator is there? 2. Left shift plus. Who is having high precedence? First tell me. As per that table, who is having high precedence? Plus is having high precedence. You ask black. You ask black. Ask A for arithmetic. A for arithmetic. Ask S for shift. So plus is having high precedence, sir. Plus is having high precedence compared to shift. You ask black. Remember, you ask black. So what will happen here, sir? Plus will work first. So now, as per the precedence associativity, plus first left shift letter. So 2 plus 3, 5. What will happen? 1 left shift 5, left shift 4. 1 left shift by 5 means you know that. Yes. 1 into 2 to the power 5, 32. 32 left shift by 4 means 32 into 2 to the power 4 means 16. So it becomes 512, sir. Okay, na? Precedence associativity you are getting perfectly. You ask black, you will able to remember. Very easily you will able to give the answer of any question, sir. Next and after that. I'm writing here int j. All the operator discussion is done now. That's I'm mixing up. Int j is equal to size of I plus plus. Printf percentile d ij. What is the answer, sir? Assuming size of integer is 4 bytes. Rakesh, assuming size of integer is 4 bytes. Yeah. So in some sense, compiler dependency is there, na guys. 12.2 is also not a incorrect answer. If size of integer is 2 byte, then automatically 12.2 is a correct answer. So better this question I should write in this way. Assuming the size of integer is 4 bytes. Predict the output of the following. Yeah. So what will happen, sir? 12 and 4. Execute, compile and perfect. We expected 12 and 4 should come. 12 and 4 is coming. Next. Tell me, what is the answer? Or 4. Okay. I don't know. We have to evaluate and reach to that conclusion. Let's see what others are telling. Okay. Let me go for it. A is equal to 2. 2 means 1 0. But what I said, 8 bit 5 6. 8 bit 2 done. Next, b is equal to 5. Let me copy this. 5 now guys. 1 1 5. Next, XOR means same gives us 0, alternate gives us 1. 1 0 alternate 1 1 0 alternate 1 1 0 alternate 1, remaining all are zeros. Remaining all are zeros. This is what you are getting after first one, and that value is assigned to A. So what is the value of A? A is equal to 7. A is equal to 7. Done. Next, B is equal to B XOR A. B XOR A means this part will be now XOR with A. What is the current value of A? 7. Current value of A is 7. 1 minute. What happened here? 8 8 8. Yeah, 7. Now this is what I will make a XOR operation. Again, 1 1 same 0 sir. 1 0 1 1 1 0 sir. Remaining after that everything will be 0. What is that? 2. Where it will be assigned? To B. So what is the final value of B? 2. Final value of A? 7. Then what is the answer? 7 2. Understanding? Everyone got the clarity? You know that. Just only thing is that maybe in hurry you are making the mistake. Seven two. Next and after that, say I'm taking here int x is equal to 10, y is equal to 20, x plus is equal to y plus is equal to 10. Print a percentile d xy. Tell me what is the output in this case? Simple. How many plus equal to is there? 2. What is plus equal to? Yes, correct. Plus equal to is such shorthand assignment operator. Where it is? Here. This is where plus equal to is present. They are known as shorthand assignment operator. If more than one is present, sir, go for associativity. Right to left na? Go for associativity. Right to left na? Oh, that means, sir, first this part will work. Y plus equal to 10. Acha, y plus equal to 10 means y is equal to y plus 10. Yes. That means y value is 20. 20 plus 10 means y will become 30. Y will become 30. Next, x plus equal to y. X plus equal to y, sir. What it means? Sir, x plus is equal to y means x is equal to x plus y. X is equal to x plus y. X is 10. Y is 30. 30 plus 10 is 40. So x value is 40. Y value is 30. Okay, na? Next. So all the operators we are practicing, guys. No operator we are leaving it. Whatever we are leaving that are related to that particular concept, there it will be discussed. Like dot operator, arrow operator. We have to wait for the structure concept to come. Next. Here int x is equal to 10. Int y is equal to, I am having x plus plus, comma, x plus plus, comma, x plus plus. Next, printf percentile d x comma y. Already we know the comma operator story. Apply it, tell me the answer. Ten 13. Achha, let's see what others are telling. 13 12. Okay. Next 12 12. Okay, let's see. Here x plus plus. Observe here. Initially x is 10. Y value we need to get. This is what we are expecting, y value. Okay, from here x plus plus. Sir, plus plus later. First x will give the original value here 10. Next I will come here na, but before coming here increment the x value. Oh, x become 11. But here in the expression what you got? 10, comma. What is current value of x? 11. Returns here. Returns means giving. Then due to plus plus x will be incremented and will become 12. But given you what? 11. Next, when you come here, again you are asking, oh x, what is your value? X is telling 12. But internally what it will do? Change it to 13. Now what it means? 10, 11, 12. In case of comma, which value is considered, guys? Which value is considered rightmost? Then which value will be considered? 12. That 12 will be given to y. And see the x value, guys. See the x value. 13, sir. 13, 12. Tell me, guys. Understanding? Comma operator also discussed. Last one. Int y is equal to 0. Int x is equal to here. Complement of y is equal to 1. Lastly, I'm printing the x value. That's it. What is the answer? Okay, 1. Your prediction is 1. Now see. Sir, y is equal to 0. Who is having high precedence? Bracket portion will be evaluated first. In the bracket portion, which part will be evaluated? This one. Why? Sir, unary operator, na sir, unary operator high precedence. Complement of y. Complement of y. Complement of y means, sir, 0 means all 0. Bitwise, na guys, bitwise complement. So it will work on bit. It will work on bit. Now what will become? Sir, all 1. Tell me guys, this number, is it equal to 1? Without even testing, we can say that. Sir, this total number is 100% not is equal to 1. I can give you the guarantee, sir. But still, if you want to verify, you know how to verify. Sir, this 1 is basically means for negative. Final answer will be -1. Final answer will be -1. But what about the value? Sir, to get the value, take the remaining number, take it, make it 1's complement, and then go for +1. What it becomes? What it becomes, guys? 1, sir. It becomes 1. But final answer is? Tell me, final answer is -1. Final answer is -1. That -1, you are comparing with 1. Is -1 and 1 are same? Is -1 and 1 are same? No. What is the answer here? 0. X value will be given to what, guys? 0. Super na boss. Execute, compile and run. Execute, compile and run. Tell me, understanding? Sir, I want to see that complement of y value as -1. Printf complement of y is equal to %d, then complement of y. Execute, compile and run. 1 minute. X is equal to /n. Execute, compile and run. Okay, now suppose anyone is asking you in this code, after this I'm printing the y value, what will be the answer? I'm printing the y value, what is the answer? Respond. What is the answer of y value, sir? Good, 0. Because after complementing y, I have never reassigned that value to y. I never reassigned that value to y. So that's why y value is never changed. Y value is still 0. If I have y is equal to complement of y, then last line value will also become -1. Complete clarity you are getting, guys? Tomorrow also we will go for few more questions, because now this is done. So arbitrarily by taking everything, we will practice few more. After that, we will enter into the flow control. Let me create the classroom for you guys. Acha, video drives are not share. 1 minute. Let me check it out. 1 minute. If not, I will ask them to share. I think they have not shared with me yet also. Yeah, they have not shared with me. Sri, I will ask them to share. I will ask them. I will talk to them today. Okay, to share that. Acha, Madhurina, why it is not possible to attend? Because they will not share the Zoom link. In this, why it is not possible? Everyone is attending. What is the problem? What is the problem? No. That is your network problem. That is your network issue. If the network issue is there, that same thing will happen with Zoom, or same thing will happen with Zoom or whatever. Zoom or webinar, basically whatever you use, first you must have the net connection. No? Net connection you have to ensure. Acha, two things guys. First let me, okay, whatever explanation got missed, you will get that in the video. In spite of that, if you are not having, then I will let you know. No need to worry for that. So let me create class. I will talk to them to share the videos as early as possible. Yeah. So this is the classroom code. Take this, and make sure you add here yourself. KZPN BTC. Okay, KZPN BTC. So current document, whatever I have, I'm sharing with you. Of course, this will be updated, guys. This note will be every day updated. Currently, up to question number 22, I prepared perfectly with explanation when with answer. 22 or 24. 25 onwards, I need to, what I need to do? Arrange properly. They are not arranged properly. Up to 24, it's okay. I'm sharing this document also, and it will be updated every day. So no need to worry. Today also I will update from 25. Tomorrow again I will share. So every day it will be updated. You will get the updated one. Only one document. Okay. And along with that, I want to share something with you. That is precedence associativity chart. Okay. That is, you may require that. Achha, signed, unsigned also you require. Along with this, just go through once, and tomorrow let me know once if anything I discussed but not shared with you. If it happens, anything is there, I will share it with you tomorrow. So just check it once. Right? Anyone joined yet? Okay, already started joining. Okay, no problem. Yeah, thank you guys.